Welcome to another video from Hegarty Maths. It's Mr. Hegarty here, our second video on stratified sampling. So in the first video we tackle problems like as follows. Pause the video and double check you can do that. And hopefully you got the following answers. So remember what I did there. I always worked out how many people in my total population. I drew a little picture showing the relationship between the sample and the population, and worked out that the population was 10 times bigger. So I divided all the numbers in my population by 10 to work out how much should be in my sample. So that's the type of thing we did in the last video. We're just going to take it one step further in this video, and we're going to tackle questions like this, where your population is divided in gender, boys and girls, and it appears here to be divided into year group. So this is what we call a two-way table, which actually we're going to do skills on later, but for now we're going to try and do stratified random sampling on it. If you think you can, pause the video and have a go at this. Okay, here what we're doing is a school is grouped by gender and year group. The head teacher wants to do a stratified sample of 80 students to find out how they like school. So the first thing, as we did before, is to work out the totals. The total boys and the total girls, add those up and you would get as follows. And then what you should do is work out the totals in each of the year groups down this column here by adding 82 and 43 and getting the total in year 7, adding 61 and 55 to get the total in year 8. So if you did that, you would get the following totals. And then you would realize that the total of the school is 645. If you add 368 and 277, you get 645. Or if you add all the totals of the year groups, you also get 645. So it's time to draw ourselves that little picture. So let's draw ourselves that little picture. Our sample, we want 80, remember. In the population, we've just found out it's 645. To work out how much bigger the population is, we do 645 divided by 80. Again, it's not going to be a whole number, but let's see what the calculator throws out. 645 over 80, and it gives us 129 over 16. So 129 over 16 is what we're going to use as our scale factor. So if you're going from sample to population, you're going to multiply by 129 over 16, and if you're going from population to a sample, you're going to divide by 129 over 16. Now, in this question it says, how many boys should there be in the sample? Well, you're only asked about boys in this case. You know in total there are 368 boys in the whole school. So all you've got to do is that number, which is in your population, divide it by 129 over 16. That should tell you how many boys in your sample. So you do 368 divided by, and you do 129 over 16 in your calculator like that, and we're going to round appropriately as well. So let's have a go at doing that. So we do 368 divided by fraction 129 over 16. And when we do that and press that button, we get 45.64, so that gives us 45.64, and we're going to round that to 46. So we're going to say 46, round up, and we're done. Now next, how many year 8s should be in the sample? Well, our year 8s, let's look at our table. In total we've got 116 year 8, so we're going to do exactly as we did before. We're going to do 116 divided by 129 over 16. So calculator out, back like this. 1, 2, 1, 6, and we get ourselves 14.39, let's say, and we're going to round that down to 14. Last one, it says how many year 11 girls. So let's identify those in our table. We want year 11 and we want girls. There are 50 in the population. To work out how many in the sample, we would do 50 divided by 129 over 16 as before. Get the calculator out, and we press back, and we would just do 50 divided by 129 over 16, and we would get ourselves the following 6.2. And we're going to round down again. So therefore we should have 6 year 11 girls in our sample. So this is an example where the population is divided into two different types of categories, gender and year group, but the same principle applies. That's it for this video. Thanks for watching.